5.3, dividing polynomials. We've been doing a lot of review with multiplying, adding, and subtracting polynomials, and now we're going to get into some new material of dividing them. Now the first example is a very simple one and one that we've seen sort of before. If I'm dividing my divisor, this is called the divisor, a number that is going into. If the divisor is a monomial, a single term, I can do the simplest kind of dividing, which means that I can split this fraction up into 3 parts. So this fraction really can be rewritten as this, where I'm saying that that 5ab is going to go into each of the 3 parts. And this is something that should feel pretty good if you think about when we are doing like our y equals mx plus b formula, and you divide by 2, you actually are dividing both of these pieces by 2. Or you could have said that and then split the fraction. So this is a familiar process. Now what happens when we get here is that we can cancel. 5 goes into 5. 5 times is 1. A squared divided by a leaves a. B divided by b is 1. So this first term becomes a. 5 goes into negative 15, negative 3 times. A goes into a once. B goes into b cubed, b squared times. 5 goes into 10 2 times. A goes into a cubed, a squared times. B goes into b to the 4th, b cubed times. And that is your final answer. So that idea of canceling of a number in itself dividing equaling 1 is something you're fairly familiar with. Unfortunately, we don't always have simple problems like that. So if just for a minute you go back to grade school and you remember doing a division problem like 5, how many times does 5 go into 1935? Well, we would say 5 goes into 15 3 times. 3 times 5 is 15. Subtract. 19 minus 15 is 4. Bring down the 3. 5 goes into 43 8 times. 8 times 5 is 40. 35. 5 goes into 35 7 times. Remainder 0. And that's our answer. We're going to use that exact same process on polynomials. So everything is going to be the same. So when I do this, here's my divisor. So that's going to be x minus 5 right here. My little dividing bar. X squared minus 2x minus 15. So now I'm going to ask myself, how many times does x go into x squared? Now remember, when we're doing this, we also lined up our place values. We're going to do the same thing here. X goes into x squared x times. So I always put that over the same term. So x is over x and x squared goes over x squared. Now I'm going to do the process. So here I took 3 times 5 to get 15. So I'm going to take x times x to get x squared. X times minus 5 gives me minus 5x. Now, what did we do in our example? We subtracted. So when I subtract, that really means I switch my signs. Because if you think about subtracting that quantity, when that gets distributed, I have negative x plus 5, negative x squared, 5x. You want to switch the signs. So now when I add, I get x squared minus x is 0. Negative 2x plus 5x is 3x. Bring down my next term, minus 15. How many times does x go into 3x? It goes in 3 times. 3 times x is 3x. 3 times negative 5 is negative 15. But remember, when I subtract, that means that I'm really going to switch my signs. And so I end up with 0 plus 0. So my remainder is 0. x plus 3 is how many times x minus 5 goes into 2x minus, or x squared minus 2x minus 15. Let's look at another example. You really just have to think about how it worked when you were in elementary school and how that works now. So here's my divisor. X minus 4 goes into x squared plus 2x minus 24. So the first thing is, how many times does x go into x squared? It goes in x times. Another thing you could think about is x times what equals x squared. That's really what we're doing. So x times x is x squared. X times negative 4 is negative 4x. And then I'm going to subtract, which means really subtract both pieces. X squared minus x squared is 0. 2x plus 4x is 6x. Bring down the next term. How many times does x go into 6x? Goes in 6 times. 6 times x is 6x. 6 times negative 4 is negative 24. Subtract those two. And so I end up with 0. So this also divides evenly in with no remainder. But if you remember back to elementary school, do a quick little example over here. Sometimes if we had something like 19 into 3901, 19 goes into 39 2 times, 38. Subtract, bring down the 1. 19 doesn't go into 10, so it's 0. Bring down the 1. 19 goes into 101 5 times. 19 times 5 is 95. Get a 6. Now what did we do with that 6? We made a fraction. 6/19. You take the remainder over the divisor and you make a fraction. That's going to be the same thing when we're dividing polynomials. So this initially doesn't look like a division problem, but really remember that negative 1 says, please move me, and that whole quantity gets moved. So I'm going to go ahead and do division. Now, I don't like to do division when my variable is in the second position, so I'm going to go ahead and reverse this and write negative a plus 2. So I just switched the order around. I didn't do anything else. So now I'm dividing negative a plus 2. How many times does that go into a squared minus 5a plus 3? So how many times does negative a go into a squared? So negative a times what equals a squared? Well, obviously it has to be a negative a, because a negative times a negative is positive. So negative a times negative a is a squared. Negative a times 2 is 2a. But remember, I'm going to subtract, which means switch my signs. 0, negative 5a plus 2a is negative 3a. Bring down my next term is 3. How many times does negative a go into negative 3a? Goes in positive 3 times. Do that multiplication, negative 3a plus 6. Remember to switch your signs. And so when I subtract, my signs get switched. So I have 0, I have negative 3. Now, there are no more numbers to bring down, so this is really my remainder. And I'm going to make that a fraction, and so I'm going to say plus negative 3 over negative a plus 2. And so when I look at this, when I look at this as my potential answer and I clean it up a little bit, I have negative a plus 3, and I'm going to switch this order back, plus negative 3 over 2 minus a. Which of my choices? Well, obviously it can't be this one. Negative a minus 3. and then, so this sign is wrong, so it's not this one. Negative a plus 3 over 2a, that looks close. Negative a plus 3 minus 3a. This negative right here, remember, could be written as a subtraction. And so D is your correct answer. Go ahead and tune into part 2 to learn about synthetic division.